The CO2 molecule is a bigger molecule with multiple components, so the infrared light will affect it and it will bend when it hits it and it will be re-radiated back down or around Earth's surface. So it will be trapped in the atmosphere. Molecules such as the N2 molecule here are not as affected by long wave radiation or infrared light because they are a tighter, more cohesive molecule and they won't bend or be manipulated by infrared radiation.
The goal of our model is to show how long-wave radiation is trapped in the atmosphere by greenhouse gases. The red ribbons represent the long-wave radiation, the plastic container represents the atmosphere, and the rods represent carbon dioxide and water vapor. The different colored rods shown in this picture represent the water molecules and carbon dioxide molecules in the atmosphere. The blue represents hydrogen, the black represents oxygen, and the yellow represents carbon. The wooden rods hide the molecules' tendency to bend when infrared radiation passes through them, but highlighted is the molecule's ability to trap heat in the atmosphere. The thermometers are manipulable gauges to track carbon dioxide, temperature, and water vapor and how one aspect affects the other two. When there is an increase in carbon dioxide, the air then heats up, allowing there to be more water vapor in the atmosphere.
During the 1650s in New York City, there was very little other than greenery. Take note of the long wave radiation represented by the red ribbons and how it can freely flow out of the atmosphere because of the lack of carbon dioxide and water vapor trapping the heat in the atmosphere. And this is correlated to the lack of human activity creating more greenhouse gases.
1750 saw more development of houses and buildings. This growth led to an increase in carbon dioxide, which then led to a rise in temperature and water vapor. As these three factors rose, it became more difficult for the ribbons to flow freely through the atmosphere. Again, the 1850s saw a rise in development. This yet again caused a rise in temperature due to trapped long-wave radiation. The radiation is becoming trapped in the atmosphere because of the carbon dioxide and water vapor. As Brian talked about before, these molecules bend when radiation passes through them. This bending causes the radiation to be refracted to another molecule, and then the radiation continues to bounce around until it eventually escapes the atmosphere.
In the 1950s now, there's an even greater amount of industrialization in New York City, and these human impacts have led to more carbon dioxide in the atmosphere, which has led to a greater temperature, which can be seen by the lack of the ability of the infrared radiation to escape the container. So now this trapped radiation will heat the atmosphere and will allow there to be more water molecules present in the atmosphere as well, amplifying the greenhouse effect.
Our current atmosphere has the highest percentage of carbon dioxide and water vapor ever in the recorded history. When looking at a chart of the carbon dioxide levels, it is clear to see the increase. Although the atmosphere is only made up of 3 parts per million of carbon dioxide, it has a huge impact on temperature and water vapor as shown through our model. Our goal was to show how there is more to global warming than just increasing carbon dioxide. Through our research, we discovered that water vapor plays a larger role in the insulation of the atmosphere than carbon dioxide. Some limitations to our model is that it does not show the source of radiation. We do not show a sun source that is heating the earth, which allows there to be a long wave radiation. Although there is a limitation, this model could be also used to show how the thinning of the ozone allows for radiation to escape easier.